Are you making an open world or semi-open world game and want to know how you can create a map of your landscape? Well, Pitchfork Academy has got you. What's up, guys? My name's MizzoFrizzo, and in this Unreal Engine 5 tutorial, I'm going to show you how to make a holographic map of your landscape. So as you can see here, I've got my whole landscape and even my player's location. So if I go back into my game and I move my character over here, for example, and make him look in the direction of this mountain and open my map, you'll see that he is in that exact location on my map, facing over towards the mountain. I'll be showing you how to export your landscapes and re-import them as static meshes, and then add those static meshes to a blueprint actor, and even how to add a render target so that you can render that blueprint actor inside of a widget, which you'll be able to access by pressing a button, which will pause your game, bring up your map widget, which you'll then be able to move around and look around using your gamepad or your keyboard and mouse, and even how to create this cool holographic material to add to your map using a custom depth render pass, giving it this really cool holographic effect, courtesy of Velocity and his magic with materials. So all of this, as you see here, will be achievable from this one tutorial. And without further ado, guys, let me show you how to do this. Alrighty, guys, now I'm here on my project, and the first thing I'm going to do is create a new open world level. So I'm going to go up here to File and New Level, create a new open world level. And once this has loaded, I'll just save it here in the content browser. I'm not even going to rename it. I'll just hit save. And the first thing I sort of want to draw your attention to is how many components your landscape is broken up into. So this one that's here by default in the sort of default open world level is really quite huge, and it's made up of quite a few proxies. You can see here, I think it might be 32 or something like that. It looks to be 8 by 8, so 64 proxies. And while my method will work on any number of proxies, you will just end up having to sort of copy paste the location of each one into your map blueprint so that it positions them and lines them up properly. But for the purposes of this tutorial, I'm just going to show you how to do it with something like 4 landscape sections. So with that all being said, I'm going to head to landscape mode and create a new landscape. And this, we can just make this something like 2 by 2 components with 2 by 2 sections or something like that. I'm just going to move this up a bit, and I'm just going to create this landscape right here. And if we head back to selection mode, that's only got one section. I'll delete that. I'm not 100% clear on how to actually create these to have more sections, but I might try 4 by 4 components, and I believe that will give me 4 different proxies. I'll create this one, and yeah, this has 4 proxies. Nice. So if you are doing a kind of large open world and you want to create a map of that world, this will work. It will just be slightly more work to sort of copy the locations of each component into your map blueprint to make sure they all line up correctly. So with that being said, I'm now going to just sculpt this landscape so it has some details on it. So that we can sort of export these as a static mesh, and you know, we'll be able to see the details that we made on there. So I'll sculpt this up and I'll get my flatten tool, and I'm just going to use the flatten tool to sort of create some geometry around my landscape. Nothing too crazy. Might put something in the middle here, and I'll just make this sort of ridge stick out from here like so. And I'll maybe get my smooth tool and make this a lot larger and smoothen all of this out so it looks all nice and soft. Nice. And that will do. Just some sort of geometry on this landscape so that we can see our map is reflecting this accurately. I'll head back to selection mode, and I'm actually going to find the player start that's on this default level and make sure that I've only got sort of one player start somewhere on the map. Where has it gone? It's all the way down here. Press end on my keyboard to bring that down to the landscape. And in the world settings, I'm going to make sure that my game mode override has the third person game mode selected so that I can play as my third person character on this landscape like so. Very nice. Let's go ahead and export these landscape components and then re-import them as static meshes for our map blueprint. So what we can do is just select all of the landscape components here. And I'm also going to show you later on how to export these individually and re-import them individually, just in case you make changes to only one section of your map so that you can update those static meshes to reflect those changes. But I'll select all four of these proxies and then I'm going to go to File and Export Selected. And I've just created this folder on my desktop. I'm just going to leave it called New Map and hit Save. And then here we can basically uncheck all of these options except for Export Source Mesh, which I haven't seen this make too much of a difference, but I do think it's a good idea to have this checked. It says something here about exporting at the highest LOD source data instead of the render data. So I do think it's a good idea to have this one checked, but it can be FBX 2013 and have everything else pretty much unchecked and hit export. And then we are going to re-import those. So let's just create a new folder here and call it map. I'm going to open this up and create a new folder in here called meshes. And in meshes, I'm just going to navigate to the folder where I exported that FBX and just drag this in. And then this window will pop up and there'll be a lot of options checked here by default. We only have static meshes, so we can force static mesh. We don't have to import LODs or bake meshes or import sockets. We don't have any bones or curve metadata. We do want to import static meshes, so this one should be checked. We have no LODs, so we don't need that one checked. We don't have any skeletal meshes or anything to do with skeletal meshes. We don't have animations, and we are going to create our own material, so we don't need to create any materials. We don't need to import textures or anything else in here. We just basically want to make sure that import static meshes is true. And it doesn't matter too much if you don't put anything here, but we can put force all mesh as type static mesh and hit import. And once those have imported, we can go ahead and open them up and you'll see we've got these neat static meshes of our landscape here. And I'm just going to go ahead and open all of these up in case I need to change anything inside any of them. And I'll also just check that they've imported properly. And they have all of the details from my landscape. Nice. Now, one thing you will notice with these is that they are quite a high triangle count, and they have absolutely no reason to be that sort of higher triangle count. So what you can do in each of these is change the keep triangle percent here. And I found that around 5%, if we change this to 5 and hit apply changes, you'll see basically no change with this mesh. And now it is, less than 7,000 tries instead of 127,000 tries or whatever it was. Now, the more detail you have on your landscape, you may need to pump this up. But I found that even lower than this makes very little difference, such as 1%. When you have very little detail like this, 1% is fine. You can also use this to kind of achieve a sort of low poly look on your map, you would have to go very low indeed, like 0.1%. That's a little bit too low. Let's try 0.25. And this is not ideal. I still think there is geometry there, but it's maybe just below the plane here a little bit. But if you wanted a sort of low poly look, you could, get this really down quite low. 0.5% and everything still looks pretty much okay. You're not even going to be looking at it this closely, and it's going to have a different material on it as well. But I'm just going to set these to 1%. And because this will only be sort of rendered when our game is paused anyway, it doesn't matter too much. But, there's absolutely no reason why this should be 127,000 triangles. So I'm going to change all of these to 1% triangles. 1%, hit apply changes. And then I'll just hit save all on these. Next, let's go ahead and create our map blueprint that will have all of these static meshes in them, and we'll create the sort of function that aligns them so that they're lined up perfectly like they are in the real world. So I'm going to go to my map folder and create another new folder and call it blueprints. And in blueprints, I'm going to right click and create a new blueprint class. And this is going to be a pawn. And the reason is we want this to have a sort of spring arm on it, and we want to be able to control this blueprint from our player controller so that we can render our map on the screen. So that's why I'm going to make this a pawn. I'll call it BP underscore map pawn, something like that, and open this up. And in here, we can go ahead and start adding some static mesh components to sort of contain our map sections. So I'm going to add a static mesh here, and let's just call it map section 0. And I'm going to duplicate this 4 times so that we've got 4 of these. And I can select the first one, press Control Space, and head to my map folder and meshes. And I'm going to drag these in order as they're named here by the proxies, which if you look in your outliner will be the same order that they're in here. So just to sort of keep them in order and easily referenced, we can select map section 0 and drag this one onto the static mesh. We'll select map section 1, drag the next one on, map section 2, map section 3. And now we've got all of our map sections here, but as you can see, they're all in the same relative location, and we're going to want these to line up properly. And that is why I have these parented to a default scene root, by the way, so that these can all have a relative offset. So these default scene roots are basically just a point in space, and then these, because they're parented to them, these can have a relative location compared to that default scene root. Now we'll create the function that will set the relative location of these map sections in a moment, but we're also going to need variables to store the world locations of these map sections. So let's create a new variable and let's just call it map section lock for location underscore 0. And this will be a vector. And the reason I've called it underscore 0 is so that I can easily, actually that has not carried over, but basically I want these to be numbered. So I'll duplicate them until I have 0, 1, 2, and 3 to reflect my map section, 0, 1, 2, and 3. And I'm just going to delete this extra one here, just so that we can easily read which map section these sort of apply to. Let's also duplicate this one more time, and we'll call this one world offset. And you'll see what this is for in a moment when we set up our function. But basically, we're going to run a function on the construction script that places all these map sections into the right position. So let's create a new function, and we'll call it something like calculate map section offset, something like that. And this is going to have a couple of inputs. The first one is going to be which map section it is. And this will be a static mesh component object reference. And we'll also pass through the world location of that section of landscape. And this will be a vector. And basically what this function is going to do is set the relative location of this map section. And we just need to do some math on this world location. Now, the very handy thing about these meshes is that they come in at exactly 1/100th the size of a landscape. Sorry, just fighting with my camera speed here. So these, for whatever reason, are exactly 1/100th the scale of the actual landscape, which is very, very handy for our little map here. And basically what it means is we can just take this world location and divide it. And we'll right click here, change this to a float and divide this by 100. Plug this into new location. And that is literally enough to sort of calculate the position of these map sections. So in the viewport here, you can see they're all still just a mess. But if we go to the construction script, we drag off of here and press S to get a sequence. Let's get 4 pins on here. And we're going to drag out our calculate map section offset. And the first one will do our map section 0 with our map section location 0. And I'm going to duplicate this 4 times. Plug in the execution pins. And replace these references. So this next one will be map section 1 and location 1, map section 2 and location 2, map section 3 and location 3. And then all we need to do is copy paste the world locations of these sections into our map. So if we select them in order in the outliner here, this will make sure that we're pasting them in the right order, because this is map section 0, this is 1, this is 2, and this is 3. So I'll select the first one and go to the details panel, right click the location here and copy, head to our map pawn, and we'll select our location 0. We need to compile here to be able to set this. We can right click here and paste in the default value like so. And we can go on through each of these landscapes. I think you can actually shift right mouse button to copy. So we should just be able to shift and click the right mouse button. And then here, select location 1, shift left click, go back to the map, select the next one, shift right click, go back to the map, select the next one, shift left click, so on and so forth, shift right click, shift left click, and you can see that that has positioned all of the map sections into the right position here. Very, very nice. Now, one other thing I'd like to add to this sort of location calculation is an offset, which is this world offset that we created down here. And basically what this means is that this default scene route here is now representing the world origin. And this map is sort of relative to the world origin in the same way that it is in my actual level. So the world origin is down here somewhere at 0, 0, 0. And then my level is slightly above it. So as you can see in the map, that is exactly how it is right here. But, you know, for the purposes of this, we don't really need this offset so much from here. So we can factor a sort of offset into our calculations, which will make our map more sort of centered on this default scene route down here. It's just a little bit cleaner in my opinion. And the way that we can do this is basically taking any of the locations from this, and this can be our offset. But if we select the last one here, the position is kind of 0 on the X and Y, and then we've got this vertical offset here. So this one will work quite well for our offset. I'm going to shift right click that one, and then in here, I'm going to paste it by shift left clicking into the default value of my world offset. And then we can go to our calculate map section offset. And all we need to do here is add this to this and then plug this into the divide like so. And now if I hit compile, oh, it's actually made it go a little bit higher. So we actually just need to negate this, this offset. It's actually the opposite of this. So we can just change that to negative 8030, and that will be in the correct position like so. The next thing I want to show you guys is how to sort of show your player's position on this map. And in real time, when you run around with your character, you can have some sort of icon or, you know, some kind of avatar showing where your character is on the map. So to do this, I'm going to parent this to the default scene root. I'm actually going to add a skeletal mesh. And the skeletal mesh I can just call player. And this, I'm going to set the skeletal mesh asset to be many, like so. And I can even change this animation mode to use animation asset and change the animation asset to be the idle. And we'll actually have a cool animated skeletal mesh of many standing on our map, showing you exactly where he is on the map. He's a little bit big though. I'm going to lock the scale here and just scale him down to something like 0.6. He's still, you know, a lot bigger than he is in the world, but it means when we look at our map, we'll easily be able to see the character. And this just really depends on how you want your map to look. You know, I'll show you how to replace this with a pin later on, just like in the thumbnail, if you prefer something of that style. So next, let's create a function that will get our player's location and convert it into something that our map blueprint can use. So we'll create another function and we'll call it calculate player transform. And this, we will just get our player character. We will get actor transform. And we can split the pin here on the transform. So we've got the location and rotation. And the location, we can just add our world offset, like so. And divide this by 100. So we'll convert this to a float. Divide it by 100. And we'll drag off of here and add a return node. And the first thing we'll return is this vector, and we'll call this the relative location, if I can spell. And for the rotation, we can drag off of here and get the forward vector of our character's rotation. We can make a rotator from the X vector. And because characters are kind of rotated by 90 degrees, if I open up my character blueprint here, head to the viewport, I don't really understand, to be honest, because it does say that this is X on the character, like so. But for some reason, sometimes characters are rotated by 90 degrees. You can see the rotation here is 270 degrees to make him line up. So there's a 90-degree difference sort of between the character's rotation and the world rotation, if that makes any sense. It might be slightly different for your player, or character, sorry, but at least with the mannequin, we actually have to get a delta rotator. Whoops, delta rotator, and just change this by 90 on the Z-axis, like so. Plug this into the return node, and we'll call this one relative rotation. Now this function, because this should always be able to return a player character, we can make this pure and it should always work. So let's select a node here and change this to pure. And then in the event graph on begin play, let's do a set timer by event. And I'm going to make this so that every 1 second, I'll set this to 1 second and looping and initial start delay -1 so that it happens immediately. I'll create a new custom event and I'll call this update player location, like so. Plug this into the delegate. And then here we can get our player's skeletal mesh here and we'll set the relative transform. Set relative transform. And I'll split this transform. We can get our calculate player transform, plug the location into the location, rotation into the rotation. And because this will always be setting the scale here, and you know, I wanted this guy to be sort of 0.6 scale, what I actually might do is just drag off of here and get a multiply node. And I'm going to make this top vector here 1, 1, 1. And I will change the bottom one to a float. And this, we can make whatever we want the scale of our character to be. So we can drag off here and promote this to a variable, and we'll just call this something like default player icon scale. And now we've got this nifty float that we can just change the scale right here as a single float, and it will update when we play. Now that should all be working now. This will loop and this will execute every 1 second and sort of update the player. And later on, we can actually call this event when we open our map to make sure that the player's location is updated every time we open the map. But if we hit, we'll actually need to drag our map out into the world until we, set up a render target and make this visible in a widget. But if we drag the map out into the level like this, and then we hit play, we can go pretty much wherever we want in this level. I'll just go somewhere really obvious, like the edge of this cliff, and then I'll press F8 to eject. And if I go over to my map, you can see that it's showing the player exactly where he is over here on the edge of this little plateau. Very, very nice. Okay, let's go ahead and start fleshing out this map blueprint so that it can sort of display the map in a widget that we can bring up in our game, and we can view this at any time and sort of rotate around it and look around it and zoom in and out and stuff like that. So to do that, let's head back into our map pawn. I'm still simulating there. And what I'm going to do on the default scene route here is add a spring arm. And this is going to allow us to sort of rotate our camera around on this map. But instead of adding a camera, what I'm going to add to the spring arm now is a scene capture component 2D. And it's basically a camera, but allows us to capture what it sees and sort of output it as a texture, which we can use in a material, which we can show on our widget. And the sort of default position of this, you can change this by just sort of rotating it around and putting it where you want. So, you could put it sort of, I'm rotating it in object space there. We'll rotate this in world space like so. And I can put it something like that. I can also change the default target arm length to something a bit longer, so we can see sort of more of the map here. But I am going to show you how to change all of this at runtime so that you can scroll in and out with your mouse wheel and zoom in and out and use the W, A, S, and D keys to also look around. If we select the scene capture component 2D, you'll see in the details panel here, it has a texture target. So we just need to create this and then assign it to this scene capture component. So let's, in our blueprints folder here, I'll right click and go to texture and render target. We can call this RT_map, and we'll open this up. and this will have a default resolution of 256 by 256, but I'm just going to make this a sort of 1080p resolution so that if you're on a sort of smaller monitor, it will fill the screen and it will just kind of always be that resolution. You don't have to do it like this, but I'm going to make this 1920 by 1080. And we don't really need to do anything else in here because this is basically a texture that will be sort of dictated by this camera here. So we can just save that render target and close it. And with it selected in the content browser here in my map pawn and my scene capture component 2D selected, I'm going to click the little arrow here and set this as my texture target. And the sort of last thing that we need to do to make this work in a widget and look really nice is create a material that uses this texture. But actually, just before we do that, in the event graph here on begin play, I'll actually put this on a sequence like so. And I'm also going to get my scene capture component 2D here, and I'm going to search for show only and show only actor components. The in actor here, I can get a reference to self and plug this in. And this means that the scene capture will only capture, things in the actual actor right here. So the map will actually need to be in the world somewhere, and this camera will be controlling it and sort of revolving it around the map to display it on our widget. And this means that it will only display things in this actual actor, in the actual map actor here. Very nice. We can compile and save that. And in our map folder here, I'll create another folder and I'll call it materials. Our render target should probably actually be in there. So I'm just going to move it in there and move here. And then in the materials folder, I'll right click and create a new material. And I'll call this m_map render target, something like that, and open this up. We can change the material domain here to user interface, and we'll change the blend mode to be translucent. Seems to be a couple of extra options here in 5.7. I'm not super familiar with materials, but we'll try this one, and we might have to change this in a moment to make this work properly. But let's just try and put this together. So I'll press Control Spacebar to get my content drawer. And in the materials folder, we've got the render target texture. We can just drag that out like so. And we'll plug the RGB into the final color. And we can also drag off of the alpha here and get a 1- and plug this into the opacity. And I'll save that. And when we apply this material to our widget, we should just see the map and what's contained in the map actor. Let's go ahead and create our widget. So in map, I'm going to make another new folder and I'll call it widget and open this up. We can right click in here and in user interface, create a new widget blueprint, a user widget, and I'll call this widget blueprint _ map. This could also be your sort of main in-game widget, and you could just play with the visibility of your widget sort of components inside of your widget blueprint. But for the purposes of this tutorial, I'm going to make it this special sort of one-of-a-kind widget. And that's how we've got it in our game. The widget is the map widget is a separate widget that appears because it's kind of separate to our in-game UI and our pause menu and so on and so forth. So I'll open up my widget blueprint here, and for some reason my my palette was collapsed all the way on the left side of my screen. That's a bit odd, never seen that before. I'm going to search for canvas panel, drag out a canvas panel, and I'm also going to search for blur and find background blur. I'll put this on my canvas panel, and then I'll select my background blur. I will change the anchor to be filling the screen here. And if I reset all of these to 0, it will fill my screen like so. And I can add some blur to this by changing the blur strength to something like 10. And then I'll get some nice background blur when I've got my widget up. I can also get an image, and I'll drag an image onto the background blur. And the image, I will change the brush to be our material. So if I bring up my content browser, I can find the material, and then I can assign it as the image right here. Now we can see the background here and everything, but on begin play, my map will sort of set this to only render. I wonder if I can actually do that on the construction script and whether this would work. So let's try putting this in the construction script, running it here, and I'll compile and go back to my widget. Yep, and that's worked. So this will only render the actual map. And I'm just going to leave this like this. So basically, I'm just showing you how to display it on the screen as a widget. However you customize this widget is up to you. I'm going to hit compile and save here. And now let's go ahead and create some inputs to sort of bring up this widget and control it from our player controller. So for me, I'm going to head to the input folder here. And because I've got the third person content pack in here, I've got IMC default and IMC mouse look. We are going to have a separate input mapping context for our map. So we're going to have to make sure we remove these and add our map, and add our map and remove these wherever necessary. So let's right click here and go to input, create a new input mapping context. I'll call this IMC map. And in actions, let's actually just create a new folder in here and call it map. And these three input actions here will actually work fine. So I'll drag those into the map folder and copy here. And then in here, I'm just going to rename these to include the word map so that I can distinguish them. I've copied two different looking ones. I'll actually use mouse look, and I'll just call it look map. I've got move map, and I'm also going to create one more input action, and I'm going to call this IA underscore zoom underscore map. And actually the one other input we need is one to open and close our map. And for that, I'm just going to copy this jump one, copy this one in here, and this one I will call just IA open map. Now we just want to make sure that the settings in these are correct. So let's start with our open map. It's a digital bool, that is correct. We don't actually need released on that one. We can delete released and we'll just have this pressed trigger. Actuation threshold at 0.5 is absolutely fine. Let's go ahead and open all of these. Our move map should be an axis 2D, vector 2D. That's absolutely fine. Our look map should be the same, a vector 2D. And our zoom map that we created, we will make this an axis 1D, a float. Apart from open map having the pressed trigger, none of these should really require any triggers or modifiers. Let's go ahead and add all of these to our input mapping context map, but I'm actually going to just delete IMC map, and I'm going to duplicate IMC default and call this one IMC map. And if we open this up, we've got a bunch of mappings here that have already got modifiers set up. So W, A, S, and D, and up, down, left, and right, the gamepad, left thumbstick, all of that is all very well and good. So we can just keep those, and instead we'll change the actual input actions here. So IA jump, we can change to IA open map, and I'll click the little keyboard icon here and change this to an M on the keyboard. I can even click this one here and press, for example, special left. So the kind of select button on my gamepad, and change it to that. IA move as WASD, up, down, left, right, and the gamepad left thumbstick is fine for me. IA look, I will just drop this down and take a look at what we got here. We've got dead zone on the right thumbstick, very good. We can add one more control binding here, and I'll just change this to be my mouse XY 2D axis. And this will just need one modifier, which will be negate, and we will negate on the X and Y axes. And the reason we want to do that is because rotating the map on the spring arm, it's not really the same as rotating around a character with the spring arm. Because with a character, you move the mouse left and you expect to look left. But because we're kind of rotating around the map and moving the spring arm on the map, this just feels a bit more intuitive. But you'll see what I mean in a moment when this is all set up, and you don't necessarily have to negate your mouse on the X and Y, but this is basically inverting the controls. So when you move the mouse left, it will sort of rotate the map left instead of rotating it right, if that makes any sense. So this should be all good now. I'm going to save this. I'll keep all my input actions and my input mapping context open for now, but I'm going to close some other tabs here, such as my render target. I'll close these static meshes of my map, just so I'm not living in tab hell. I'll compile and save my map pawn. And now basically we want to bring the widget up that this scene capture component is, fed into with that texture. So let's open up our third person character, or whatever character you're using, and go to the event graph. And let's start with our IA map. Actually, you know what? I'm going to do this in the player controller. Now in 5.6, I believe it was, and onwards, the third person content pack in the third person game mode came with a player controller class. And if you look in your game mode override here, or inside of your actual game mode, and your player controller class does not have a player controller class that you can browse to, such as this one here, BP third person player controller, you will just want to create a new blueprint class of player controller and assign that to your player controller class. But if you're in Unreal 5.6 or onwards, you should have one here in the template, or if you're working on a sort of more fleshed out project, you probably will want to have your own player controller class. And the reason for that here is that player controller is actually a really good place to spawn your widgets from, because the player controller is sort of persistent. Even if the character is to sort of die and be destroyed and you create a new one, the player controller class will sort of persist through events like that. You also only have one per machine that you're controlling characters and other pawns from. So it's a really good place to spawn your widgets. And in the template, you'll see that in the player controller, it's adding the mapping context, IMC default and IMC mouse look on begin play. And we actually want to remove these and add these as we bring the map up, so that we're using our mouse and our WASD for something else when we're actually looking at the map. So, these might be inside of your player controller if you're using an older version of the engine up here on begin play. And if they are, I would actually recommend taking that logic and putting it inside of your player controller class like this, because it will just be a bit easier to manage. And with that being said, I will actually just duplicate these nodes down here, because we are going to have to add these and remove these input mapping contexts when we bring our map up. But this has actually just reminded me that we will also need our IA map inside of our IMC default, so that when this is the active mapping context, we'll still be able to bring the map up. So let's go back to our input folder and IMC default, and I'm going to add one key mapping here. And actually what we can do in our input mapping context map is find our open map input action, right click this and copy all properties in group. And then in our IMC default, we can then find our empty one that we've just added, and we should be able to paste this in. Hold on. Let's change this to open map and paste maybe. Nope, that hasn't worked. We may have to do each of these bindings in turn. So that's made that M. Very good. We'll add one more, and our gamepad special left, we'll copy that and paste that in here. Gamepad special left. Very, very good. Now we can open our map with our IMC default. And if we go to our player controller class, we can find our IA open map, and we can use this to sort of show and hide our widget and change our input mapping context. But just before we do that, let's actually create our widget on begin play. So I'm just going to move this stuff over a little bit. I'll drag off of here and press S to get a sequence. And on begin play, actually, let's do this after the is local player controller. So that will make sure that we're only spawning the widget on a local player controller. So let's just add a pin to this sequence here, and we will create widget. The widget we'll create is our widget blueprint map. We can promote this to a variable, and we'll call it map widget. And we'll add this to the viewport, but then we will also make it hidden by default. So we'll get our map widget, and we'll set our visibility, and we'll set it to hidden, like so. So we're creating it, we're adding it to the viewport, but we're making it hidden. And this is sort of a bit more efficient. Rather than creating and destroying it whenever we need it, we will just sort of have it there in the background hidden, and we'll make it visible when we want to see it. So I'll grab these two nodes here and Control D to duplicate them down here, because we will need this. And I'm actually going to make this pause the game when we want to view our map. So what we can do is we can check is game paused, and we can drag off of here and press B to get a branch. And if the game is not paused, we are going to set the visibility of our widget to visible, because we are going to pause it. So if the game is not paused, we will pause it and we'll make this visible. So we'll just start off by making this either visible or hidden, like so. And these will be run up here in a moment, but let's just duplicate this enhanced input local player subsystem, get of this subsystem, and we will remove mapping context, and the mapping context we'll remove is our default and our mouse look. So let's just find them in input, IMC default, and set this one to be IMC default. We'll duplicate this, plug in the target, select our mouse look and assign this. So we're removing IMC default and our mouse look. And we can duplicate and add mapping context, plug this into the target, and select our map and add our map context. So now when we pause the game and make this visible, we will remove the normal mapping contexts and we'll add the IMC map like so. And vice versa, when we when the game is paused and we're hiding our widget and unpausing our game, we will add our IMC default and mouse look. But first we will remove our map IMC and go back to our normal input mapping contexts that allow us to run around and look around with our character like so. And we don't actually need two of these, but I think that looks fairly neat like that. So I'm happy with that. And then when either of these is run, what we can do is grab our isGamePaused here and get a not boolean, and we can set game paused as whatever it is not. So if it is paused, it will set it to unpaused, and if it's not paused, it will set it to paused. And we can just plug this in like so. Now this will kind of work to make our widget appear, but the thing is, if we're going to pause our game, we also need to set up our inputs to work when the game is paused, and we also need to set our map to tick when it is paused. And on that note, we can also make our map not tick if our game is not paused. So it's not ticking if we don't need it and we can't see it. So to do that, let's create a reference to our map. And here, when we're sort of, on begin play, creating our widget and whatnot, we can also just drag off of here and get actor of class. The actor of class we're going to get is our map pawn BP. And you don't have to set up your graph like this, but I'm just going to keep it neat and legible like so. And here I'll promote this to a variable and I'll call it our map pawn. And then we've got a reference to our map pawn. Now you just want to make sure that you only have one map pawn in your level. So I'm going to use this one and make sure that I only have this one here so that it gets this one and sets the reference to it. You could also spawn it from here and create a reference to it, but I'm just going to keep mine in my level. And if you do have yours in your level and you're using world partition, you will probably want to change is spatially loaded to false so that this thing is just always loaded and in your persistent world. And now that we have this reference to our map pawn, we can get our map pawn and let's set tick enabled, set actor tick enabled. Duplicate this up here, plug in the target. And if our game is not paused, we're pausing it, making it visible, and setting tick enabled to true. And then if it is paused and we're unpausing it and hiding our widget, we set it to false. And now if we go to our map pawn, we can also just start with tick enabled as false. So this actor will not tick until we set it to tick. And it means it just basically won't do anything. It will basically be, in the background, just waiting for you to bring up your widget and use it. But if we look under advanced here, we've got tick even when paused. And this absolutely needs to be true. And it needs to be true for anything that you need to tick in your map pawn when you bring it up. So we're going to make sure that we set our player and our spring arm and our scene capture component 2D in here. We can leave start with tick enabled because actor tick is turned off anyway, but we do want to go to advanced. It might not work on scene capture 2D. Tick even when paused. Scene capture 2D apparently doesn't need it. If we search for tick, start with tick enabled. Tick even when paused. So yeah, you do want to make sure that you set that to tick even when paused for all three of these. And in fact, anything else you add to your map that you want to be able to work while your game is paused, make sure it is set to tick even when paused. And the other thing is we want our inputs to work when paused. So I've got all my input actions open here, and it is for that very reason. I want to enable trigger when paused on all of these input actions. Trigger when paused, and trigger when paused. That's why I kept these open. So I'm going to hit save all now because we've made quite a lot of progress. And I will close these input actions now because I don't think we'll be needing them anymore. So now that IA open map has trigger when paused set to true, we haven't set up looking and moving around the map yet. But if we hit play now, and I wait for the startup jitters to go away, I can press M on my keyboard and I'm bringing up my map like so. And I press M, it should go away. We're getting quite a lot of lag here. I might actually delete the huge landscape that's below us because we've got multiple landscapes here. It's also still preparing shaders. But if I move my guy over here to this cliff and I press M, he is standing on that cliff on the map. Very, very nice. I'm just going to go ahead and delete this extra landscape because my performance is tanking right now. So it's this first landscape, and actually to delete it, you have to delete all of the proxies. So I'll shift click and select all of those and delete them. And then once the proxies are deleted, you can delete the actual landscape actor like so. Still says video memory exhausted. That might be because I've got a separate project open in another window here. So I'll change its scalability to low. And hopefully that fixes my video memory exhausted warning. I have lowered it a little bit, but that's fine. Okay, let's go ahead and add the ability to look around and move around on our map via our widget when we've paused our game. Now, we are going to sort of add this functionality inside of our map pawn, but I'm going to control it from my controller because we have a reference to the map pawn. And I've just had some issues when prototyping this with sort of consuming input actions on this map pawn because you would kind of need to possess it, but we don't actually need to possess it to make this work. So instead of sort of complicating this with some added possession logic of this pawn, we're just going to call out input actions in the controller and have the controller consume them and call custom events inside of our map pawn, if that makes any sense. So let's go ahead and find our IA map. What do we call it? IA move map. We can find our IA look map, and we can find our IA zoom map. Very, very nice. Now we've got these action values, and these action values will need to be the inputs on the functions inside of our map pawn. So let's go to our map pawn here and go to the event graph and find some empty space and create a custom event. And I'll call this one add movement. I'll create another one and call it add look rotation. And the last one, we'll just call it add zoom, something like that. Now these first two will need inputs, and we'll call this action value, and I'll just Control C that, and this will be a vector 2D right here, vector 2D. Do the same with our look rotation, add an input and call it action value, vector 2D. And on our zoom, add another one, action value, but this one will actually be a float because our zoom is just scrolling on our mouse wheel, and it's just either +1 or -1. Now, I did forget to set zoom up properly in the input mapping context. So I'm going to head to IMC map, and we created zoom, but we didn't add it here yet. So let's add this. Look for our IA zoom map. And I'm going to click the keyboard here and scroll the mouse wheel. So set this as mouse wheel axis. I'll also add 2 more. This one, I'm going to click this and press the left trigger, but actually that sets it as axis. So I'm basically setting this to L2 and R2, and how I'm going to do that is go to gamepad, and it will be the left trigger digital. And this just makes it on or off with the left trigger instead of having it, be analog. We can click this other one and find gamepad, right trigger digital. I'm going to add a modifier to our mouse wheel axis. I will add 1 modifier. This will be negate, and I'll negate it on all axes. And it's for a similar reason to what I talked about with the look and negating the look in the mouse 2D axis, because similarly, if we want to scroll out, we're going to want to add to our spring arm length and not reduce. So this just removes the need for doing extra math when we consume this input and we sort of calculate what we want to do on the spring arm. So I'm going to set that to negate, and I'm also going to set the left trigger modifier to negate. And that just means that the right trigger will be a sort of positive effect, and the left trigger will be a sort of negative effect, if that makes any sense. I'll save this and head back to my map pawn. And I'm going to make some more space for each of these because these can actually become quite substantial. And what I'm going to do when I add movement is I'm going to get my spring arm, and I'm going to get its relative location, and I'm also going to set its relative location. And basically, I'm going to use the action value from my input to add to this relative location. I'm going to actually right-click the new location here and split this so that I can have different clamp values on each of these values. And I'm going to add to the relative location like so. What I'm going to do is right-click the action value and split it into the X and Y. And I'm going to calculate this in a very similar way to how I calculate the movement in my character. So in the template character, for example, if we look in the move function here for IA move, we have X and Y that's fed into this function for moving. And it basically gets the control rotation, the right vector of the control rotation, and the forward vector of the control rotation, and uses it to calculate our sideways and our forward and backward movement relative to where we're looking with our controller. And we can do this very similarly, but with the rotation of our spring arm. So we'll go back to our map pawn here, and I'll just duplicate this get for the spring arm, and I will get the get relative rotation like so. And I can right click here and split this, and I will get the right vector, get right vector, and I'll also split this, and I will also get the forward vector and split this. I'll plug the X into the X here and the Z into the Z, and I'll also plug the Z into the Z on the forward vector. And then this right vector we can multiply by the action value X, and the action value Y we can multiply by the forward vector. And both of these we will add to the relative location like so. And we can right click this and split the struct pin, plug the X into the X, the Y into the Y, and the Z into the Z. And the reason I've split these is so that we can clamp them individually to change how far we can sort of move with our map. So we can try this out now. I'm going to hit compile and save and hit play, and I'll full screen this. And if I press M to bring up my map, I'm not actually calling the function yet. My mistake. So in the controller, when we trigger our IA map move, we can get a reference to our map pawn, and we can call our add movement function that we created and pass through the action value like so. Sorry about that. Forgot to actually call the function. And try again, press M, and that is not actually working. Why is that not working? I'm very sorry, guys. I forgot in the map input mapping context to change all of these. So I changed this one to open map, but I need to actually change these to IA move map and IA look map, IA zoom map. So these were still set to the input actions that, that our character is using, not the special ones that we've got here that we're using, that we're calling when our game is paused and the map is visible. Sorry about that. That should be working now. I'll full screen this, try once more, press M to bring this up. And now we can actually move around the map. Very, very nice. Although it is very slow with W, A, S, and D and the arrow keys on the keyboard. And if we pick up controller and we use it, it's also quite slow. So what you can do to change these inputs is just change the scalar in the actual input actions. So if we go back here and find our IA move map and open this up, you can add a modifier in here to scale this. If we find scalar, we can, sort of scale this by 2 for all of our IA move map, or in our IMC, we can do it individually for different things. So you could, have a different scalar on your left thumbstick than you do to your W, A, S, and D. But I'm just going to add the scalar to the actual input action so that now if we hit play, we can move. Sorry, I've got a little bit of lag here, startup jitters. We can sort of move at a more reasonable pace. And this scalar, you might actually need to change individually for things like looking around, which we will look at next. So I'm happy with IA move and that scalar change. So I'll close that and I'll keep my IMC open for now. But in our map pawn, let's go ahead and start looking at adding some look rotation. And before I forget, let's go ahead and call these custom events in our controller so I don't make the mistake of not actually calling them. I will duplicate this and I will add, add look rotation like so, and pass through the action value. And for zoom, I think it's called add zoom, and pass through that action value. Nice. We'll go back to our map pawn and we'll add some look rotation here. How we want to do that is once again get our spring arm, and this time we're going to set the relative rotation. Plug this in, and I will once again split the struct pin on this so that later on I can add some clamps so we can only look so far up and down. I'll also get the relative rotation of our spring arm, and I'm going to drag off of this and get a delta rotator. This allows us to just basically change the rotation, or basically make a rotator that's relative to this rotation. I can right click here and split this. I'll also split my action value, and the action value X here will need to plug into the Z, and the action value Y will need to plug into the Y. Then I can split this one, and I can just plug the Y into the Y and the Z into the Z. And we'll add some clamps to this shortly, namely to the pitch, to make sure you can't look up and down too far. Actually, this one's pretty straightforward. We don't need to test to sort of know what values to put in here. So we can just put a clamp float on this, plug this in here. And this, you know, you can limit this to something like -85 so that you can't look all the way down. And you can set this to something like -15 so that you also can't look under the map, if that makes any sense. And this also sort of prevents it from wigging out if you look, you know, completely vertical. It can, because, you know, we're not using quaternions in Unreal Engine 5, it can break things a little bit. So it's good to have these clamps. You can even set this to like -89.5 and it will sort of stop that from happening. But I like these figures. And now that this is in here and we are calling it in the controller, we can now try this one out as well. I'll press M to bring up my map, and I can now rotate my map and move it around as well. And if I try to look up, it will stay at 15 degrees. So this is the clamp at the bottom end here, -15 degrees. And if I try to look down, I can look pretty much straight down, but that's clamped at 85 degrees to make sure I don't break it. Very, very nice. Now we can go ahead and add some zoom by changing the spring arm target length on our map pawn. So once again, I'll just make sure that this is being called in my controller, and it is. And then here, when I want to add some zoom, I can once again get my spring arm and I can set the target arm length. I'll put this here and I'll duplicate it over here to try and keep things neat and tidy. And I can get my target arm length and basically just add this action value to it like so. I will want to clamp this, so I'll get another clamp float. And basically we want to clamp this spring arm, its target arm length to, you know, sort of within reasonable values here. So I've found that values of around 150 to about 550 work well for me. I'll plug this into the target arm length, but this will actually be very, very slow because this action value will only be 1 or -1. So this will only add 1 unit, 1 centimeter to your spring arm every time you do it. So we could try multiplying this here, but I think it's better to use scalars inside of your actual input actions so that it's sort of, you know, it's sort of happening before here and you're not having to do this extra math. So in our IMC default, sorry, not IMC default, I'm looking for IMC map in my input folder, IMC map, and I'm looking for my IA zoom map, and I might actually make my scalar different whether I'm on controller or on mouse. So we might have to play around with this a little bit, but I'll add a modifier to my mouse wheel here, add one modifier, scalar, and let's try something like 5, 5, 5, 5. And I won't scale my gamepad just yet. Let's test this out and see how this feels. So I can hit play once more and I'll press M to bring up my map. And now when I scroll my mouse wheel, I can zoom in and out. Nice. And if I pick up my controller, I can also zoom in and out with that. Now, it really depends how you want to have this set up. I've got it set up so L2 sort of zooms in and R2 zooms out. You may want to negate those values or not negate them based on how you want that to act. So let's have a look once again in our IMC default and what we set up here. And we set it up to negate on the left trigger. But if you wanted it to be opposite, you could just delete that. And you could add the negate modifier to your right trigger instead. And I'm also going to go ahead and add a scalar modifier and make this 555 to both of these. Add a scalar modifier to my right trigger as well, 555, and test this out. And that means I can sort of zoom in and zoom out with R2 being zoom in, which is very nice. And it's a little bit faster than it was before. Nice. Now this 150 distance with the spring arm might be a little bit close. You want to change the values on your clamp float node if you want to sort of, stop that from getting any closer. Now, just before I go ahead and show you how to put a nice holographic material on this map, courtesy of Velocity, let's take a look at the clamp on the movement to make sure that we can't sort of move too far on this map and sort of just, move the spring arm endlessly off to sort of one end. So what we can do is clamp the X and the Y here before we set relative location on our add movement function. And what we want to clamp these to, we can actually just have a look in the viewport here. If we select our spring arm and we look at the X value here, we can sort of move that over to one side of the map. And you'll see that at -300, it's just beyond the edge of the map here. And if we move it over this way, around +300 will be a nice clamp on the X. And we can take a look at the Y and it should be very similar. We can clamp it between -300 and +300, and that should be very, very nice. So let's grab a clamp float and I'll duplicate this one here. This one will be the Y. Plug this into the X and this into the Y. And we'll do -300, copy that onto the other one, and +300, and copy that onto the other one there. And we'll just quickly test that that is working. I should only be able to move over to the edge of the map and then not really any further. You could clamp this a bit more tightly if you wanted to, not be able to move so far past the edge of the map. But this works for me, just so that I can't endlessly move further and further away from the map so the player can't actually do that. Very, very nice. Try that with controller, and I can move around, I can look around, and I can zoom. And just on controller, I do sort of want to point out, actually with the mouse as well, that the way we've got this set up so that right sort of rotates the map left, and similarly, or actually sort of opposite with the controller, it all just depends how you set up your input actions and how you negate those action values. So I'm not going to go into it any further than that, but if you did want to, you could, put a print string on this look rotation function and print your action value X or your action value Y. And then you can play around with negating those input actions. So, map actions and look map. And we didn't put any modifiers on here. We actually did it in the input mapping context on our look map. We've got our modifiers on our mouse to negate that. And we actually didn't put it on our look map. So that's the difference there. You can play around with these modifiers by negating, certain axes and printing those out. And that will sort of give you an idea of what's going on here. You could also, as I touched on earlier, you could sort of multiply these by -1, but that extra math is not really required. You should just have your input actions set up, in the correct way. And actually, one other thing I want to show you before we add a material, a nice holographic material to this map, is how to sort of center the camera on the player position when we open up the map. And then after I show you how to add the material, we'll also add a little sort of location pin on the player location in case you wanted to do that instead of showing this character. So what we can do in our BP map pawn is up here with our, set the player location here. I'll also create another custom event, and I'll just call it on map activated or something like that. So we're going to run this when we open our map. I'll also create a custom event and call it move camera to player or something like that. Move camera to player. And for this, we can actually use this nifty calculate player transform pure function that we created earlier. And we can just get our spring arm and we can set the relative location of our spring arm to be the location of our player, like so. And if you wanted to sort of set your camera to have a certain height above your player or above your map in general, what you can do is basically just, set this to be above, let's say 80 units above, like so. And this way, because we're not actually changing the vertical location of our spring arm with any of our functions, it will just kind of stay here at this 80 units above, as long as we are setting this here by adding this and right-clicking here and splitting the struct pin and adding this default value here. You could always, promote this to a variable as well and just call it default camera height or something like that. And if I compile, the default value will be taken from here, which was 80. And then on our on map activated, let's press S to get a sequence, and let's update our player location and also move the camera to the player. You don't have to do this, but updating the player location is a good idea because this only happens every 1 second, and we want this to be up to date when we open the map. And I'll also move camera to player, and then in our controller, when we bring up the widget and we've got our map pawn here, we can also just make a little bit of space here and just call our on map activated, like so. Nice. And let's test this out. Press play, press M to bring up our map. And if we move our map way over here, for example, and I close it and then reopen it, it is centered on the player again, which is really nice. It means that, as soon as you open it and it's on the player, you can start rotating, and it's just rotating around that player position. So you sort of, you're orientated the same way that you are in the real world as you play, and you can sort of see where your player is. Alrighty guys, one of the last things I want to show you is how to create a really nice holographic material for this map, courtesy of Velocity. This is a pretty fancy yet very simple material to set up. So in our map folder and materials, I'm going to right click in here and create a new material. I'll call it M_holographic or something like that, and open this up. And straight away, I'm going to leave the material domain as surface, but I'm going to change the blend mode to additive and the shading model to unlit. But the other thing I need to do in here is search for custom and allow custom depth rights. And that's because we're going to be using a custom depth render pass on this material, which sort of makes you only able to see the pixels that are, the first pixels that you see. So you don't see the backside of the material, even though it is a sort of additive, sort of see-through material with opacity. We'll only see the sort of front side of it. So it has a very nice holographic effect. But just before we go ahead and set up the rest of this, on that note, we also want our meshes to have a sort of custom render pass enabled. So we can go to our map pawn and we can select all of our map sections here and search for custom. And we want to enable render custom depth pass like so. And this will make sure that the material works on these once we have set it up. So the first thing I'll do in here is hold V and click to get a color parameter. We can call it color, and let's just make this like a nice lightish blue sort of color. It has a nice effect, and plug the RGB into the emissive color. And then we'll go ahead and set up the custom depth logic. Now, I don't understand all of it. As I've said before, materials are not my strong suit. I've just sort of got the setup of this material from Velocity, but I'll do my best to sort of walk you through what's happening here. So first, let's find a pixel depth node, and we'll drag off of here and get an add node, and we'll hold 1 and click here to get a constant, and we'll just make this -1 and plug this into the B like so. And basically this is getting the pixel that's in front. So if this is a sphere, it's getting the pixel that you see on the front side, and it will sort of ignore the pixel at the back, if that makes any sense. We'll also find a scene texture, this one here, and here the scene texture ID, we'll drop this down, and this basically allows you to get a bunch of stuff from the scene. And the one that we're looking for here is our custom depth, like so. Off of the color here, we can find a component mask. Whoops, if I can spell that correctly, component mask. And we only need the red channel here, so we can just uncheck the green channel. So it just says mask R, like so. I believe we can hold I and click to get an if node here. The add from the pixel depth here will go into the A. This mask will go into the B. And we'll hold 1 and click here twice to get 2 constants. And we'll make one of them 0 and one of them 1, like so. And this one will plug into here, and this one will plug into these 2 pins here, like so. Now, like I said, I don't really understand exactly how all of this works. Velocity would be better at explaining this to you. But basically what we're going to do now is just add a Fresnel, which is a kind of edge fade, which will give us some extra contrast and definition around the edges. So we can right click and search for Fresnel. And the exponent in here, we can right click and promote this to a parameter, and we'll just call it something like edge fade. And you don't want to go too high with this. I'm going to start with a value of around 3. You can play with this, but just be warned that, if you go too high, it can sort of wash out the sort of image on your map and not look as good. But off of the Fresnel, we can find a multiply node, multiply it with the if right here. And then this, I believe, we plug into opacity, and we've got this kind of nice edge fade holographic look to this material. And that is pretty much it. I do believe this material will work as is. So let's find it in our content browser here, mholographic, and go to our map pawn. And I can just select all of my map sections and then click the little arrow here to set this as the material on these meshes. And you'll see that that custom depth pass means that we can't see through the geometry, but we kind of do see through it. We just don't see through it to the sort of backside of the mesh. And this Fresnel is the kind of glow that you get around all of the sort of peaks and hills on your map. So now if we hit play, and I'll full screen this, and I press M on my keyboard, we can't actually see our map at all now. That's cool. What is going on? It may actually be because our render target material doesn't allow for custom. So let's take a look in the material here and the render target texture. I wonder if this has any custom depth pass. It might also be in our map pawn, the scene capture component. Does that allow for any custom depth pass? Ah, you know what? The material for the render target, we have this translucent gray transmittance, which I don't believe in older versions of the engine you had these different versions of translucence, but the colored transmittance, yes, there we go. That is showing up on there. Let's just make sure that that works in the game. Ah, now we're getting the kind of background in the sky as well. That's very, very odd because we are setting this to sort of only render in the construction script, wasn't it? Only render the actual components from this actor. But one of the things we could do to sort of prevent this happening, and it is very common that you would have something like this just out of the way somewhere in your game, such as under the map. So we could just put this under the map and perhaps put it in a little room so that it doesn't, capture anything like the skybox, this weird stuff that was happening here. So for example, we could just add some cubes and sort of build a little room around our map so that it's blocking anything from the environment. I'll scale this cube up nice and big. And just before I duplicate it, I might actually just create a simple color material. We've got this basic shape material. If we browse to it, it's in the engine content. So what we could just do is drag this to our materials folder and make a duplicate. And then in here, open this up. And I'm just going to change this to black, like so. Save that, close that, and apply this to my cube. And then if we just hold Alt and rotate this, sorry, I'm getting quite a lot of lag in the editor right now. I'm not really sure why that is. I'll just hold Alt and I will make a couple of duplicates of this cube and make a little room around my map. Now that we have all of these walls, I'm just going to shift click and select all of them, including the map, like so. And I'll just move out to double check that I've got everything here. Nice. And I'm just going to put that below my level, like so. This wall is not quite in the right spot. There we go. And you just want to make sure that the map is kind of centered in that room well enough so that the camera boom doesn't have the render target going outside of this little room. Just put it more or less in the center, like so. And now if we hit play and I bring up my map, it's still rendering the skybox. That is so strange. Now this is an issue that we didn't get in 5.6. So I may have to come back to you in the comments section and, pin a comment with a fix for this because I'm not exactly sure what's going on there. But as promised, I am going to show you how to sort of have a little pin on your, on your map instead of the player in case you wanted something like that. So in the engine content, and if you can't see the engine content, you can click the little cog here and show engine content. If we filter by static mesh, we've got a bunch of static meshes in the engine content. And in here, if we search for, I believe it's teleport, we've got this teleport direction mesh, which is a nice little location pin looking thing. If we just drag this to our meshes in map folder here and copy here, we can then add this to our map pawn by, now you could even just hide the player here. You could replace this with a static mesh actor, but instead I'm just going to add the static mesh actor to the player, and I'll just call this pin, and this we will set to our pin, and I'll just rotate this 90 degrees and maybe 90 degrees this way so that it kind of turns to face wherever our player faces, and just move it up so it's kind of above his feet or right where his feet are, like so. We can make this a nice yellow color by grabbing the material that we duplicated here. Just turn all my filters off. Our basic shape material, we could actually create a material instance from this and just call it MI yellow, and then open this up. And right here in the parameters, we can check the color here, change the color to yellow, and then save that. And in our map pawn, I might actually just set the material of the actual mesh here. So I'll just go ahead and open the teleport direction mesh and then get my yellow material, drag it onto the material so that my pin is yellow. And then in the map pawn, I can just hide the player here. So I'll just search for visible and uncheck visible. And I can also turn the animation off here and clear the skeletal mesh so there's just nothing in there being computed. And now we have a pin. And we'll have to check the scale on this pin, but since it's parented to that player component, we should just be able to change the scale of the player component, and it will change the scale of the pin here. So if we go back to our event graph where we've got the default player icon scale here, we can just change that to something like 0.2, and it should make that pin a bit more of a reasonable size. There we go. Very, very good. Actually, there is one thing I promised to show you, which was how to re-import these meshes if you made a change to your landscape meshes here. So I'll quickly show you how to do that. Let's go back into landscape mode, and let's just say I sculpted a big mountain over here, something very, very obvious that we would notice if it wasn't on the map, like so. And let's say I've only made changes to this one section of the map like I have here. We can see it's the first section of the map here. I can just, with this map section selected, go to File and Export Selected. I'll navigate to my map folder here, and I won't overwrite this original one, but basically every time I need to re-export this section of the map, I will just overwrite the same file. So I'll just call this new map 1 and hit save, leave all of this as it was and hit export. And then the static mesh right here, I can right click this and re-import with new file. And I'll just select that new map 1 that we just exported, re-import with that new file, and you can see it has been updated there. So if we hit play now, we've obviously got this huge new mountain here. We bring up the map, that is reflected in our map because we re-imported that static mesh like so. And guys, that's it. If this video has been of any use or value to you whatsoever, please hit like and subscribe, and I'll see you on the next one.